The next presentation is coming from Torstein Haarberg. He's managing director at BNW-Energy. He will talk about super PV approaches towards LCOE reduction. So, Torstein, the floor is yours.
Thank you. Do you see my presentation?
Yes.
Thank you very much for this opportunity to present some results and perspectives from super PV. I am Torstein Haarberg, and my co-authors are Juras Ulbikas from Protec and Philip Massé and Elena Bosch from Becquerel Institute. So I will first give a short project overview, and then main part of the talk is on LCOE assessments before some concluding remarks. And one initial remark, this presentation is 1 out of 3 from the Super PV project in this webinar, and is complementary to the presentations by Robert Wittek 2 days ago and Julius Denafas a bit later today. So the focus in this presentation is on performance assessment using LCOE, levelized cost of energy, as a tool. So first, a little bit about the project. Super PV started out as a Horizon 2020 Innovation Action in May 2018 and will end by November 2022, after a short limited extension due to COVID. The project is pursuing an ambitious but realistic goal for innovative PV systems, cost reduction, and significant reduced LCOE up to 37% by adopting a hybrid approach combining technological innovations and data management methods along the supply chain for solar. And to achieve this, key actions are implemented at 3 main levels within the supply chain. We have the PV module innovation level, mainly happening in Work Package 3 modules presented by Robert Wittek the other day. Then we have Work Package 4, power and also communication electronics innovations. And in Work Package 5, we have system integration level. Very important to remember is that the upstream part of the solar supply chain is not a part of the project scope. Already from the beginning, we established a result assessment methodology by defining 6 key performance indicators from the start: solar module cost reduction, balance of system components cost, total installation cost, performance ratio of the lifetime, reduction of life cycle costs per kilowatt hours, that is the LCOE, and finally recyclability and environmental footprint of solar module. So it should be clear that the integral effect of KPI 1 to 4 can be expressed by the or manifested by the LCOE. So the LCOE is the central parameter to investigate in order to assess and understand the performance of most innovations in the project, both individually and at the integral level. A bit about the background for super PV exploitation strategy. Here is a market snapshot from third quarter 2017 to second quarter 2018, showing among others a price reduction of solar cells about 40%. Why is that important for us? Or the question might rather be how to deal with such dramatic price reductions in the market already before the project started, because as you saw in the previous slide, there was a solar cell price reduction of about 40% from the submission of the Horizon 2020 in the third quarter of 2017 to project start in the second quarter of 2018. Super PV response to this is twofold. First, the upstream solar supply chain is, as I said, not a part of the project. Hence, cheaper solar cells in the market is actually an advantage for Super PV. Likewise, of course, with other innovations outside the project scope. Secondly, several Super PV innovations are targeting enhanced energy yield and performance ratio, and are even more beneficial at higher solar cell efficiencies. And as we see here, these are pictures from latest versions of the ITRPV reports 2021 and 2022. Solar cell efficiencies are indeed expected to continue to increase. Here we see a status for Super PV prospective innovations at month 36. Here we see project innovations with an anticipated lifetime up to time to market, not lifetime, time to market, with up to 3 years after project end. So we have 4 innovations from Work Package 3 modules presented by, these were talked about by Robert Wittek the other day. Then we have 5 innovations from Work Package 4, Communications and Power Electronics, module level Power Electronics Smart Box by Protec, Dual Stage Microinverter by COSILab, Wireless Communication Gateway also by COSILab, and IoT Management Platform. We have finally from Work Package 4, Environmental Meteo Station by the University of Ljubljana. From Work Package 5, System Integration level, we have monitoring and smart operation and maintenance with digital twin from IESA, and BIM Solar by CAD-Commission. BIM stands for Building Integration Management. So at this point, things are still looking promising. Now to the main part, LCOE assessment. First, a little bit about overall ambitions and corresponding LCOE reduction. LCOE sensitivity will be discussed shortly, before turning to some concrete project examples, just to show how to use LCOE as a tool to assess performance of certain innovations. In this case, multifunctional coatings and the performance of high albedo surface material for bifacial models, before finally turning to integral assessments. So here we see the initial ambitions for cost reductions and corresponding LCOE reductions on CapEx. 10% reduction gives a certain calculated LCOE reduction, and further on with OpEx, lifetime, extended lifetime, reduced degradation, enhanced performance ratio, and finally introducing bifacial modules. To some extent, this figure also show kind of a sensitivity of these variables towards the LCOE. And the cumulative effect of the proposed innovations were 37% improvement, or and LCOE at 63% compared with the original benchmark. One variable that is not included here, that has a huge impact on the LCOE, is the discount rate, or the used in the LCOE calculations. So when you calculate the LCOE, you need to discount future earnings and costs, and what you use as the discount rate is typically the weighted average cost of capital. And here we see a huge influence on the LCOE from the weighted average cost of capital. So a 3% percentage point change in the WACC gives 25 to 30% change in the LCOE. And it is interesting to notice that the LCOE is even more sensitive when operational expenses relative to installation costs are lowered. So the advantage of reduced capital costs is even larger if you are able to lower the OPEX/CAPEX ratio. Now to the concrete project examples. First, how to assess the performance of multifunctional coatings. Potential revenues are higher energy yield from higher transmittance and lower module temperature due to less infrared radiation and from less soiling. And also potentially lower operational and maintenance costs from less frequent cleaning operations. Costs are higher CAPEX from initial coating and higher OPEX from later coating additions. And technical specifics and performance was presented 2 days ago by Robert Ritek. Now, here we have cost metrics, coating costs, durations, and also some anticipated gains, performance ratio, and cleaning costs. What you need to do first is to translate these cost metrics into present value for the worst case, and from the worst to the best case. Then translate this present value of coating cost per square meter to a present value of annual operations and maintenance cost per square meter, and finally ending up with annual coating operating cost due to replacement of coatings per kilowatt peak, which then will be a function of the solar module efficiency. So if you have a 20% solar module efficiency and the coating cost with 2 euros per square meter with a duration of 5 years, you end up with 1.7 euros per kilowatt peak. This figure also shows what I mentioned a bit earlier, that these innovations, like several other innovations in the project, are even more beneficial at higher solar module efficiencies. Now we take this last figure here and use that to try to answer the main question: what is the integral effect of all costs and revenues? And the response to that is actually to calculate the LCOE change as a function of changes in OPEX and changes in performance ratio. And profitable, of course, if the change resulting LCOE is lower than the initial LCOE. So this figure shows also a kind of window of opportunity for different coatings. So if you end up with the most expensive coating with the shortest duration with no other gains in OPEX, you actually need 5% increased performance ratio. Of course, we don't have the responses to this yet, but of course, still we have the methodology. Responses will be, of course, are investigated in WERPACT 6 demonstration. Now to the other second project example, bifacial modules. Potential revenues are higher energy yield from module backside due to the high albedo surface material. Costs, higher CAPEX and higher OPEX from material replacements and cleaning operations. So to assess the performance, we need to quantify the yield gain from enhanced albedo. And of course, we need to know the cost of the material. And then we will be able to assess how much extra operating cost one can allow for such a material to be profitable. So a material with 70% albedo is identified at a tentative cost of 0.5 euro cents per watt peak at 20% module efficiency. And an albedo increase from 30% to 70% due to this material may give 5 to 7 enhanced yield according to this literature reference. This is also, of course, depending on geographical location. So now we can ask the question, at what operational cost will it be profitable to use this material? And the response is to calculate the LCOE to find the balance between increased costs, OPEX, and increased revenues by enhanced yield. So this figure shows extra OPEX costs as a function of enhanced yield, the blue line here represents a constant LCOE. So such a material will be profitable if one is able to be below this this line. Figure also shows that if you're able to replace the material more seldom, of course, the window of opportunity for profit is bigger. What remains to be assessed, of course, is the initial capex addition, albedo degradation rate, and potential albedo material cleaning costs. Now to integral assessments. We realized that new prospective innovations from Super PV combined with price reductions and improvements elsewhere in the solar supply chain can form winning combinations in the market, leading to substantial reductions in the LCOE. To the left here, we see relative LCOE comparison with the original benchmark. So this number we have seen before, that was the original ambitions, but if you combine updated data for Super PV innovations with recent prices for components not part of the project, then we can become even much lower. And here we see absolute values for LCOE compared with a projection of a market benchmark for 2023. Both calculations are done at a discount rate of 7%. And we see that the Super PV best estimate is competitive by projected market benchmark for 2023 as a function of yearly solar irradiance. So now I'm at the end of the talk. In concluding remarks, the levelized cost of energy is described, and we have shown examples for using LCOE as a tool in assessing the performance of individual innovations. And at the integral level, new prospective innovations from Super PV combined with price reductions and improvements elsewhere in the PV supply chain can form winning combinations in the market, leading to substantial overall LCOE reductions. Thank you for the attention.
Thank you very much, Torstein, for summarizing these results. It's really very interesting. And actually, I just want to catch up some time for the panel discussion. So it would be nice if you can answer the questions in the chat function.
Definitely. Thank you.
Okay. Thank you very much.